Hey, let's take a look at that last page. Just problems 9 and 10. Okay, so let's see what we can do. Shouldn't be too bad. So what I have in number 9 and 10 is I've got this big, huge graph, and I wanted to know, first off, a possible answer. So because it didn't say find the answer, but it said find a possible answer, we would have something like this. So the first thing that I notice is that there's a root right here at 1. So I'm going to grab that one as x minus 1 squared because you see the little bounce that happens there. I also see a nice little cubic here at 3, and I know I'm a little bit out of order because I also saw a nice little linear factor come through right here at x plus 1. But keep in mind, I don't know what that leading coefficient is that makes that happen. But I did say that I wanted it to happen somehow so that g of 4 is 9. So if I plugged in the number 4 for all of the x values, 4 plus 1 is 5. 4 minus 1 is 3. 4 minus 3 is 1. So when I put it all together, I have 9, because that's what we set it equal to, is equal to a times 5 times 9 times 1. So a equals 9 equals 45a. So a is 1/5. And so I've got a nice little equation that is 1/5 of x plus 1 times x minus 1 squared and x minus 3 cubed. And for what it's worth, in my key, I have this thing right here matching up with this one, trying to demonstrate that that was a linear factor. I have this one right here matched up right here with this guy right here because I wanted to see specifically that that was a quadratic factor. And then last but not least, I had this one right here with the same color as this one right here, trying to demonstrate that we had that nice little cubic factor happen. So that was number 9. That was a pretty quick one. And then the last one had to do with domain and asymptotes, because that's kind of a big deal for people when we get deeper, especially into these problems. So the first thing that I would like to do is I'd like to take a look at this problem from the lens of looking at where this is 0. And so I did make this denominator nicely factorable to 6x minus 1 times x plus 4. So right away, I can tell that in terms of a domain that I do not want to have 1/6 and I do not want to have -4, because if either one of those things happen, I would be in fact dividing by 0, which is something that we're just not allowed to do. Now, as it turns out, neither one of these, see, I can't factor this anyway, but clearly the number 4 is not a factor because of the rational roots theorem, and 1/6 isn't a root because of the rational roots theorem too. So there's no common factors. I don't need to worry about removable discontinuities. But what I can see in this problem is that at x equals 1/6 and x equals -4, these two are vertical asymptotes. So please notice this says don't be, this says don't be these values, because if you did, you'd be on an asymptote. And the other thing is, because of the ratio of the powers, 3x squared over 6x squared, they're matching powers. We have a horizontal at 3/6 or 1/2. So that's again one of those end behavior asymptotes. I would say the limit as x goes to either positive or negative infinity of function f of x would be 1/2. That would be my horizontal asymptote. Now, this next one, as it turns out, doesn't have them. Square roots don't tend to do that. As x gets larger and larger and larger, and you take the square root of those numbers also get larger. So that's not really an issue. But what I can do is I don't want to take the square root of a negative. So I looked inside here and I noticed that everybody here has a 2 and an x. So if I took out the 2 and the x, I'd be left with x squared, 5x, and 4, which means I could factor it one more time as x plus 4x plus 1. Now, again, the better you are at factoring a lot of these problems, just get quicker, let's just face it. So personally, I like to make a little sign chart, a plus and minus chart, and I know that my roots are at -4, my root is at -1, and my root is at 0. And what I can see is, again, just making sure everybody gets that. See, there's a root here at 0. there's a root here at -4, and there's one more root here in the middle at 1. But if I put the number above 0, like 10, and I plugged it in, I get a positive times a positive times a positive, and I can take the square root of positives all that I want. But anywhere in here, if I tried -1/2, this would be negative, this would be positive, and this would also be positive. If I tried in here, like -2, I'd get a negative here, a positive here, and a negative here. And a negative times a positive times a negative is actually positive, and I can take the square root of that all that I want and get positive numbers. So it turns out for this problem, I am allowed to be in here and I'm allowed to be in here because I can't take the square root of negatives. And so my domain would be everything from -4 until -1, and then everything else from 0 to infinity. And keep in mind, I can take the square root of 0, so I'm not excluding those values where the zeros actually happen. And last but not least, let's look at this guy. Now, if we factored this thing, and I very, very much on purpose made it a very easy factor since it was the last problem on this review. I know that the numbers -5 and +5 are bad guys. I can't do that. I would be dividing by 0. So I know that's going to be outside the realm of possibilities, but there's something else. I know that at 3/5, I divide and I would have 0 on top, and 0 on top is okay. But interestingly enough, as I try to move numbers around, anything that I try out here works. Like if I plug in 10, I could take the square root of 50 minus 3. That's fine. If I plug in 10, nothing bad happens here. If I try in the middle here, it's great. Plug in 3. 5 times 3 minus 3 is perfect. You can divide. But everything out here is just no, 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 no. It's bad at -5 because I divide by 0, but it's bad on either side because I'd be taking the square root of a negative. So my domain is actually from -3/5 until 5, and then everything from 5 to infinity. And so that's my domain. And so as it turns out, the only asymptote that I have is I've got an asymptote at x equals 5, which is a vertical asymptote. And I have another one at y equals, I got to think about this one for a second. Yeah, 0. Now, that's again my end behavior, and the reason why is because the power of the numerator is actually x to the half power, and the power of the denominator is an x squared, and since the power of the bottom is larger than the top, that automatically makes 0 an end behavior asymptote. Again, there's nothing going to the left, but the limit as x goes to positive infinity of k of x would be 0. Notice I can't go to the left because it doesn't allow it. So there's only one side that it has that horizontal asymptote. Hopefully that was helpful, and I will see you back in class. Bye-bye.